Assalamualaikum and a very good day to everyone. Today I'm attending the 18th IEEE International Colloquium on Signal Processing and Application. I will be presenting my study regarding the investigation on the effect of the ferrous particle size on the impact absorption capability of magnetoreological elastomer. And it is prepared by Associate Professor Dr. Hizbullah Huda as a main author and me, Normidata Salah binti Sobi, as a presenter and a co-author, and Kavin Subandram, Nur Akmal binti Hanifah, Dr. Zulkifli bin Abdul Kadir, and Dr. Sabirin bin Rahman. Moving on to the introduction. So what is MRE? MRE is the magnetoreological elastomer that is a smart material with very mechanical properties and the magnetic field when the magnetic field is applied. MRE can contain various sizes of ferromagnetic particles in their composition. The optimal size of the ferromagnetic particle to achieve the maximum impact absorption capability in MRE for cycling loading is determined in many studies. However, the studies that validate the maximum impact absorption capability under the influence of carbonyl ion Ci particle size for impact loading are still limited. And from the figure, the common matrix MRE with ferrous particle, which is CIP, where the CIP is scattered, while when the magnetic field is applied, the CIP become aligned. This is the uses of MRE in impact mitigation application. So the first one is the MRE isolator, where the MRE is put between the magnetizer, and next one is the vibration absorber, which this is the schematic diagram of the vibration absorber, where the MRE is put at the damper. Moving on to the study. So my study starts with the fabrication of the MRE, where MRE has three main components. There are rubber, ferroparticles, and binder or hardener. So in this study, ferrous particle contain three sizes, which are 20 micrometer, 40 micrometer, and 60 micrometer. The fabrication starts with the mixing process, where the RTV silicon rubber is mixed with the Ci particle and hardener, and the mixture will be poured into the mold. And then it will be cured for about 24 hours, and it will be put into the MRE test device and ready to be tested in the drop impact test. So this is the materials composition and also the variables for the drop impact test. For the material, we use RTV silicon rubber for about 70%, which is 21 gram, the carbonyl ion particle, which is 30%, for about 9 gram, and the hardener, which is the 3% from the amount of carbonyl ion particle, which is 0.27 gram. And the variable for the drop impact test is where the impact energy is, we use 11 joule, and the impact velocity 2 meter per second. The falling height is 204 millimeter. The tub holder mass is 4.3 kilogram. The tub nominal mass is 1.2 kilogram, and the specimen support is 3 millimeter, with varying current from 0 to 2 ampere and 0.5 step. So this is the drop impact test setup, where we have the PC setup and the data acquisition, and also the drop impact test machine, and the MRE test device is located at the specimen holder. To the result. So referring to the figure, this is the characteristic result where the 20 micrometer of MRE material, the impact absorption device is tested by evaluating the performance of the device in two state conditions, which are off-state and on-state condition. The off-state condition is not apply any current on the MRE coils, while the on-state condition was applied the input current to the MRE coils. Based on the results obtained, The impact absorption device featuring MRE was able to produce the maximum force of 5,654.76 Newton at a maximum input current, which is 2 ampere. Meanwhile, the off-state condition, the impact absorption device was able to produce 5,087.62 Newton. Moving on to the 40 micrometer of CI particle size, the results obtained where it produced the maximum force of 6,205.22 Newton at a 2 ampere current. Meanwhile, the 0 ampere current are 5,254.42 Newton. Last one is the 60 micrometer CI particles, and the results produce the maximum force of 6,305.31 Newton at a maximum current, which is 2A. Meanwhile, for the off-state condition, which is 0A, it produced 1,234.37 Newton. This is the overall result for particle size and also the current. The MRE material with CI particle size of 60 micrometer that is tested in on-state condition with an input value of 2 ampere current shows the highest response of damping force. Comparatively, the MRE device with 60 micrometer CI particles has the highest vibration damping device than the MRE device composed with 20 and 40 micrometer CI particles. Since the MRE device with CI particle size of 60 micrometer that is tested in on-state condition absorbs the highest impact energy, the desired CI particles for maximum impact absorption is determined. The optimal size of ferrous magnetic particles to absorb the highest impact energy is determined through the response of damping forces. Carbonyl ion particle with the size of 60 micrometer in on-state condition absorb the highest impact energy. So moving on to the conclusion. In this study, the properties and behavior of magnetorheological elastomer was studied. The laminated magnetorheological elastomer isolator was designed to achieve the optimal magnetic flux density of MRE. The performance of the MRE materials were tested under impact loading, and the study proved that the size of CI particles influenced the response of damping force in MRE under impact loading. The higher response of damping force in MRE under impact loading attenuates the variation in MRE. Also, the greater size of CI particle and higher lateral stiffness can give the higher response in damping force to absorb higher impact energy. Based on the results provided, the optimum size of CI particles to absorb the highest impact energy is MRE with 60 micrometer CI particles in on-state condition of 2 ampere with 6,305.31 Newton damping force. The response of damping force and the impact absorption capability of MRE can be increased further if the size of CI particles are increased more than 60 micrometer. Since the scope of this study is subjected to only 20, 40, and 60 micrometer size of CI particles, the CI particles with 60 micrometer tends to be the best size in impact absorption performance. Thank you.